There is something profoundly unsettling in places where the universe seems absent, where no stars shine, no galaxies dance, and not even dark matter dares to gather. These are the zones of cosmic silence, the voids, regions so immense they dwarf our imagination, and at the same time so empty they seem like the very opposite of existence. But what are they really? Are they mere anomalies in the distribution of matter, or clues to a greater and still unknown cosmic order? Why do some of these zones, like the Eridanus supervoid, seem to hold mysteries that defy our known physical laws? And what if these voids are not simply empty? In this journey, we will travel through the dark folds of the visible universe, explore still unexplained anomalies, and push to the edge of scientific theory, where a fascinating and unsettling hypothesis takes shape: the existence of other universes that may have left marks, traces, scars in the very fabric of our cosmos. In the grand tapestry of the universe, not everything is filled with light. Cosmic voids are enormous regions of space in which matter, stars, galaxies, gas, is almost completely absent. Unlike the dense galactic filaments that make up the so-called cosmic web, the gigantic cosmic web that structures the universe, the voids appear like bubbles of silence embedded in the fabric of existence. Some of these deserted spaces have been known for a long time and bear names as mysterious as they are fascinating. There is the Eridanus supervoid, stretching across about 1 billion light-years and at the center of heated cosmological debates. Or the Bode's void, one of the emptiest regions ever observed, so much so that its borders almost seem to define an unexplainable absence. And then there's the local void, much closer to us, which surrounds our local group of galaxies as if we were immersed in a galactic island surrounded by nothingness. But how do these voids form? According to current cosmological theories, the universe formed from tiny density fluctuations present shortly after the Big Bang. Over time, gravity attracted matter towards certain zones, creating the filaments, while other regions emptied out, giving rise to these immense cosmic deserts. Their existence, however, is not just a scientific curiosity. Some voids seem too large, too perfect, too anomalously empty. And it is from here that the deepest questions arise. Among all the strangeness of the cosmos, one anomaly particularly disturbs scientists. It's called the cold spot, a mysterious cold patch detected in the cosmic microwave background radiation. The fossil echo of the Big Bang, the oldest message ever received from space. This region, located in the constellation Eridanus, is significantly colder than the surrounding areas of the sky, a fact that, according to the standard model of the universe, should not occur. Temperature fluctuations in the cosmic microwave background are indeed expected, but that of the cold spot is so large and marked as to suggest something unusual is at play. And here enters another cosmic protagonist, the Eridanus supervoid, a vast area almost devoid of galaxies, which seems to overlap exactly with the position of the cold spot. The most accepted hypothesis, at least initially, was that the light of the cosmic radiation passing through this low-density region had undergone an effect known as the integrated Sachs-Wolf effect. In practice, light loses energy while crossing a void, cooling down. But there's a problem. The supervoid is not empty enough. According to many studies, its density alone would not justify such a marked cooling. In other words, there is something in the cold spot that still escapes understanding. Some scientists hypothesize it's simply a statistical coincidence. Others, less conventional, put forward theories that open the door to far more disturbing possibilities. Cosmic collisions, parallel universes, events never recorded in the history of modern astrophysics. But one thing is certain: the cold spot is real, measured, confirmed, and still today represents one of the deepest and most fascinating anomalies in the entire observable universe. To better understand the cold spot anomaly and the Eridanus supervoid, it is important to explore the concept of the Sachs-Wolf effect. This phenomenon concerns the behavior of the cosmic microwave background radiation when it passes through areas of the universe with lower matter density. According to the theory, when the cosmic microwave background radiation passes through a cosmic void, it undergoes an energy loss, as the gravity of a low-density region causes a stretching of the electromagnetic waves. This effect was theoretically predicted to explain fluctuations in the radiation, especially in low-density regions, like those observed in the Eridanus supervoid. In other words, the Sachs-Wolf effect suggests that cosmic radiation may appear colder in void zones due to an energy reduction while traversing low-density spaces. However, as mentioned earlier, the density of the Eridanus supervoid is not low enough to justify such a marked temperature drop, raising the suspicion that something more complex underlies the phenomenon. With the cold spot in the Eridanus supervoid continuing to challenge our understanding of the universe, alternative theories are emerging that go beyond traditional models. One of these is the theory of cosmic inflation, which suggests that our universe, immediately after the Big Bang, underwent a period of exponential expansion. But what if this expansion did not occur in a single isolated universe? Imagine that our universe is part of a network of parallel universes, each expanding, but separated by invisible cosmic boundaries. According to the bubble inflation theory, some of these universes may collide, leaving cosmic scars in the universe we know. This theory suggests that the universe, like a series of bubbles, may have collided with another universe in its early stages. A cosmic encounter that may have left visible traces in our current observations, such as the cold spot and other cosmic voids. In other words, what we see as voids may be remnants of ancient interdimensional collisions, that is, remains of interactions between parallel universes. Supporting this theory, recent studies published in Scientific American and Physics World raise the hypothesis that these cosmic voids are not mere anomalies, but scars left by cosmically significant events. One of these studies in particular highlights the link between cosmic voids and the theory of collisions between parallel universes. Multiverse theory and its implications. Bubble cosmic inflation. Each universe exists in a separate bubble, expanding independently, and collisions between them could occur during the universe's primordial phases. Interdimensional black holes. Recent theories suggest that the anomalous behavior of some voids could be explained by interference with black holes located at the edges of different universes. Cosmic density function. Some models propose that voids are not empty in the traditional sense, but may represent transition zones between universes, where the matter density is lower due to these cosmic collisions. The provocative question: if the cosmic microwave background is our window to the beginning of the universe, then cosmic voids might be the scars left by collisions between universes. But is it really possible that the universe as we know it is the result of a cosmic fusion? The multiverse theory and the possibility of interdimensional collisions push us to rethink what we know and to look at cosmic voids in a completely new light. They could be the echo of something far greater than we expect, a testament to worlds that collide and merge in the vast and mysterious stage of the universe. The possibility that our universe interacted with another in the very first moments after the Big Bang represents a scientific and philosophical revolution. Discovering this would radically change our view of reality, raising new questions about what the universe truly is and where its boundaries lie. If another bubble universe had touched ours, then our universe would no longer be unique but part of a larger whole. This would turn cosmology from a science that studies the universe into one that explores universes. Cosmologists are already analyzing the cosmic microwave background in search of circular patterns or thermal anomalies that cannot be explained with standard physics. Some simulations show that collisions between universes could leave circular imprints or asymmetries in the map of the primordial universe, marks left by the contact between two different realities. The concept of a multiverse challenges everything we believe to be real. If infinite universes exist with different physical laws, which one is the true universe? And if collisions with other universes influence ours, we might be the accidental result of cosmic events we have no memory of. Some theorists suggest that our universe is a kind of three-dimensional projection of two-dimensional information, an idea known as the holographic principle. If this were so, a cosmic interference, such as a collision with another universe or a macroscopic quantum anomaly, could cause distortions or imperfections in this projection. In this context, cosmic voids might be glitches, distortions in the very fabric of reality, like imperfections in an image projected onto a screen. It's an extreme hypothesis, but it opens the door to new questions about the link between information, space, and consciousness. As always, we invite you to subscribe to our channel. It's a small gesture that helps us immensely and ensures you won't miss future updates on topics you won't find just anywhere. Maybe we are not alone. Maybe our universe is just one bubble in an ocean of worlds that collide, touch, transform. And those cosmic voids, which today we consider anomalies, may actually be closed doors, forgotten scars, or silent messages from other universes. The question is no longer, are we alone in the universe? But is our universe only the beginning of something much greater? Thank you for joining us on this new journey through frontier science, cosmic mysteries, and forgotten knowledge. And now I leave you with a thought, or perhaps a riddle. There is something that escapes logic, yet calls to intuition. A bridge between what we are and what we could be. You cannot see it, but it watches you. You cannot touch it, but it reflects you. It is not your world, but it resembles you. What is it? Hi, I'm John. Our journey into mystery continues. If you want to uncover more hidden truths and answers to the greatest enigmas, leave a like, subscribe, and hit the bell. Together we'll explore the unknown. And who knows what secrets we'll find.